because that's a solid. So you have to be consistent in the way you write the chemical equation with the way the K is given. So write your chemical equations in this chapter with the solid on the left and the ions on the right. You're not going to like it when you're doing the homework. I guarantee you're not going to like it. But maybe with a couple examples we get used to it. So, what are the concentrations of barium and sulfate? Well, let's go back to this. It says assume the reaction goes to completion. We're going to assume that it goes to the left all the way to completion, but we need to know what the dilute concentrations are. You see how we have barium solution, or barium chloride solution, and potassium sulfate solution. Those get combined. Our volume 1, V1, of the barium concentrate, or the barium solution is that. M1 is that. We're going to have to use the dilution formula, M1V1 equals M2V2, to find what the new dilute concentration of barium is. What would it be? V1 is 75 milliliters. What's the new volume, V2? 200 ml. Yeah. So M1V1 equals M2V2, solve for M2, and what do you get? Anybody? .0075?
I agree.
Yeah.
Okay. How did I do? Did I get it right? All right, now the SO4, I don't remember that one, so it's up to you. So your M1 is 0.04 for the potassium sulfate. V1 is 125, V2 is 200, so what is M2? The dilute concentration. Anybody? 0.025? I think that's right. Okay, so these are the dilute concentrations. Does it look like a precipitate's going to form? If the K value is 1.5 times 10 to the negative 9, Q would be that number times that number. Is that going to be greater than 1.5 times 10 to the negative 9? Yeah. You should just tell, yes, it is. So if a precipitate's going to form, it's going to shift left. Now, what I was saying on the previous slide was, and hopefully you wrote that down, assume that the precipitation goes to completion. So you're going to go all the way to the left. It's not going to stay all the way to the left, but we're going to go all the way first. So that means we're going to do like we did last chapter. Find the limiting reagent. What's the limiting reagent between those two? The BA. So that's going to go to 0. And this is going to go down by that amount, which is 0.0175.
Yeah.
Oh, M1V1 equals M2V2. Because they get diluted. When you combine two solutions, you got to use the dilution formula. Okay? So I just took M1 times V1 divided by V2, which is those two combined, the volumes combined, to solve for the new molarity. Okay, so that makes some barium sulfate. Do I care how much barium sulfate? No, I don't care at all about how much barium sulfate is made. Just the fact that some solid was made is all that matters. And in that process, the barium has run out now, and so however much solid was made is done being made now that I've run out of the barium. So, from this point, now I make my ice table. That's what I mean by modified ice table. You have to first do this step to get your concentration. So barium sulfate is a solid. It doesn't really have a defined concentration. But one of my products is 0. Can it stay at 0? No. You can't have something be at 0 at equilibrium. So it's got to be made. So the reaction is going to shift back to the right. All the way? No. Because it's going to come to equilibrium. So it's going to go down on the left side by some amount x, and on the right side it's going to go up by x, and this is going to go up by x. So that at equilibrium, this is going to be x, the amount of that solid that dissolved, and that's going to be 0.0175 plus x. And now from there, I know my k value is 1.5 times 10 to the negative 9. That's equal to that times that. Solve for x. So can I neglect that positive x?
Yeah.
Yes. Because x is tiny, because the k is so tiny. So it's negligible compared to 0.017. So the k, which is 1.5 times 10 to the negative 9, equals x times 0.0175, which is, by the way, too many sig figs. But we'll keep them for now and round later. Neglect that plus x term, and what do we get for x? 8.6 times 10 to the negative 8. Woo, that's not very much. Assumption's good, definitely. We didn't need to worry about that x term. So the barium concentration is 8.6 times 10 to the negative 8 molar, and the sulfate concentration is that with a molarity sign on it.
Some more.
Yeah.
We're supposed to keep track of the same things because shit,
Yeah, when I subtracted those, this really should be 0.018.
yeah.
Yeah. So when my final answer, I would have cut that 5 off of there. Yes, Justin.
I still don't understand. How do you F1 V1?
These?
Yeah.
When you combine two solutions, now there's more volume for the ions to float around it because the volume went up. The volume went for the barium solution, it started with 75 ml, but then you add another solution, it went up to 200 ml.
Yeah.
So this is the dilution formula.
You can do it twice for each one.
Yeah, you had to use this formula twice. One for the barium and one for the sulfate. Did you miss that, something about that the first time?
I understand that, but then after I saw it, I'm like,
M1 for the barium, M1 is 0.02 times 75 divided by 200. The V2 is 200 because it's 75 ml added to 125 ml. Are others getting this? I think this is right.
Yeah, we
If you like your numbers also outside.
Got it now? Hey, what did it say, Jess?
That's what I'm getting at. Like, actually. No, I'm not even kidding. It makes sense. Like, wait, you have the 200 at the bottom, you cancel out the 2, so you cancel out the 10.
Yeah.
And then that's what you get.
Devin, we good? I'm not going on until you got it. Okay, okay, okay. Justin? Okay.
Same thing,
I'm going to ask you to try one. Give you a few minutes. Go ahead if you have any questions about any of this. So when you have the initial amounts and you know a precipitate is made, shift it all the way to the left until something runs out, and then it drifts back to equilibrium. That's what I mean by drifting it back, because you can't leave that barium at 0. It didn't really totally run out. And it's easier to do the calculations that way, where you go all the way to 0 for one of them, and then you have it drift back to equilibrium. It doesn't drift very far back, because look at that concentration, it's small.
No, that's for the barium. So for it'll give you 0.06.
Yeah, for the SO4, you're going to take
But for the other
that M1 times V1 divided by 200. All right, I'm going to ask you to try one. This is a very similar problem. It's a different precipitate that's made. See if you can work through this. Come up with the concentrations of the ions at the end. Yeah.
I've had a question. So like, you know when you like make a picture of a like computer screen, why does it like show up like lines? Like you can see the lines on the computer screen. It's really weird.
I don't know. Let's find concentration of ions. I know about that.
Curious.
Yes.
Do we really care about the same thing when we're doing
No, not much. We do at the end, not in the middle. And at the end, just use 2 sig figs and it'll be fine for all these ones that had capes. Okay. Raul, try this problem. You'll be pleased.
It's not extra credit, it's like extra credit.
Oh, do that.
Go ahead and talk through it if you want to, if you're not really sure if you're doing the right thing here. You don't know that your concentrations are. We have to use the dilution formula again for this one.
We get a quadratic and then we solve that, right?
Nope. You can make an assumption.
Oh, yeah.
Yeah, assumption's good.
I don't know, that's all. I did. Tried it. And then later, when you do ice cream, you also do 2x.
Right. I know you do it there.
Okay, because you do it at the top. That's what I did. What's about how do you pay 5%? Oh, so the answer's the same thing.
Oh, right.
Then the answer's the same thing.
All right, are you on your way for this one? Can I go ahead and start putting the problem up here? You want to go too soon?
Because it won't affect the ending if you do 2x. You just like get rid of the 2x. So I don't know if you
Like, you know what they trust the rate. You know what the extra words are that?
I'm gonna graph it.
Yes, it is. It's gonna work. It's something. Yeah, not that.
Yeah, it gives the same thing. Use 2x or x for the ending. But for the, this part. Right here.
I messed up on this one last hour, and I wonder if any of you did, or if you're sharper than me. The amount that this goes down You have to multiply it by 2 for the amount that goes down. Did you